Hello everyone, we are solving problems on the superposition theorem. In that, first question is, for the circuit shown below, the source voltage is increased by 10%, then the power dissipated across the R4 resistance is increased by dash. This is the given circuit. Okay, in the question, what he is asking, the source voltage is increased by 10%, then what is the power dissipated across the resistance R4? Before increasing the voltage source, the voltage across R4 is V4. Okay, voltage across R4 is V4. It is VR4. Let it be VR4 is equal to V4. Now, if you observe this, all these elements are resistors. Resistors means this network is linear network. Okay, so in case of linear network, if excitation is multiplied by some constant K, so the response is also multiplied by constant same value K. So here 10% is increases. So now what is VR4? VR4 is equal to 10% increase means 110%. So if you remove percentage, this you will get 1.1 V4. In this case, what is power? Power PR4 is equal to V4 square by R4. Okay, now what is PR4 dash? New power VR4 dash whole square by R4. Okay, substitute this value in this equation. You will get PR4 is equal to 1.1 V4 whole square divided by R4. So you will get PR4 dash. This is new value. Okay, after excitation increases. So you will get 1.21 V4 square by R4. So V4 square by R4 means PR4. So what is P4 dash is equal to 1.21 PR4 before excitation. That is before increasing excitation. If you observe this, so this is 121%. So 121% means, so how much increases? 21% is increases. So the power is increased by 21%. Next question is, in the following circuit, find the current I by using superposition theorem. This is the given circuit. So he is asking current I by using superposition theorem. We are finding the response of any branch by only one source acting alone and other remaining sources are switched off. Switched off means if current source is there, you need to replace with this open circuit because the internal resistance of current source is infinity. Now the voltage source is replaced with short circuit, that is the internal impedance of or internal resistance of voltage source is 0. First case 1, I am considering 3 volt source acting alone. If 3 volt source is acting alone, then this 1/4 ampere source is open circuit. Circuit becomes like this. Okay, so here the response, let it be I1. Now find the I1. So what is I1? I1 is equal to 3/4, 0.75 amps. Now case 2, current source is acting alone, that is 1/4 amps source acting alone. Circuit becomes like this. Okay, here the response due to voltage source is I1. Here the response due to current source is I2. Now if you observe this current is 1/4 amps coming towards to this node. Whenever this current is reaches to this node, here there are two paths. One is short circuit path, another is 4 ohms. So current is always short circuit path only. Current is flowing always short circuit path only. So current never goes in this path. So this is 1/4 amps. So now what is I2? I2 is equal to 1/4 amps, that is 0.25 0.25 amps. Now by superposition theorem, so what is the response? The total response I is equal to I1 plus I2. Okay, this is the total response. So this response is due to 3 volt source acting alone and due to current source acting alone. So totally I1 plus I2. So total I is equal to 0.75 plus 0.25. You will get I is equal to 1 amp. Okay, or you can find out this current directly. So the voltage across this 4 ohms is 3 volts because these 3 elements are connected in parallel. So the voltage across this 4 ohm is 3 volts. The current flowing through this 4 ohm is 3 by 4. Okay, if you apply KCL here, this is I is equal to 3 by 4 plus 1 by 4. You will get 1 amps directly. Okay, if examiner mention in the exam a particular method, then you need to solve using that method only, particularly in case of descriptive exams. Next question is, in the following network, find the current I by using superposition theorem. This is the given network. So by superposition theorem, what we are doing, only one source must be acting alone. So consider case 1. Case 1, 18 volt source acting alone. So if 18 volt source acting alone, current source must be open circuit. Then circuit becomes like this. Here the response due to 18 volt source is, let it be I1. Okay, now what is I1? I1 is equal to 18 by 6 plus 3 because this is open circuit. So no current is flowing through this branch. So this is open circuit. So you will get 2 amps. Now case 2. If 9 amp source is acting alone, what will happen? The 18 volt source must be switch off. Switch off means here it is short circuit. That is, we are replacing this 18 volt source with internal impedance or internal resistance. Then circuit becomes like this. Okay, here the branch current I is I2 because this is a response due to this 9 amp source acting alone. Now, so here the current source value is, this current source value is 9 amps. That means here the current is 9 amps. Here 2 resistors are connected in parallel. You can apply current division rule, but current must enter into the 3 ohms resistor here. Okay, because the current is enter here, so current must go in this direction. But the current is coming towards to this node, so you need to take minus, that is negative. So by current division rule, what we are getting, I2 is equal to opposite resistance 6 by total resistance 3 plus 6 into minus 9. So you will get, this is minus 6 amps. So by superposition theorem, what is I? I is equal to I1 plus I2. So 2 minus 6 is equal to minus 4 amps. Okay. If you want to cross check this circuit, you can apply either nodal analysis or mesh analysis. You will get same answer. Okay. In the next video, we will discuss some more problems. Thank you for watching.